Hi everyone, welcome to Focal Academy. In this problem, here how to find current I1 of S and I2 of S. So here given the circuit in terms of time domain. So source was given as 10 into u of t and one resistor 1 ohm, here 4 ohms, here 1 by 4 Henry inductor, here 1 Henry. So having two loops are there. Now asking that how to find current I1 of S and I2 of S. In the first step, convert this time domain circuit into the frequency domain circuit. So like this. So for this apply Laplace transforms. You will get 10 into. So Laplace transform of u of nothing but 1 by s. Important point here. So impedance for resistance, that is nothing but equal to resistance only. So for inductor the impedance is SL. For capacitor the impedance is, that is 1 by SC. So these are the important formulas whenever you are doing Laplace transforms. Now here for resistor the impedance is nothing but resistance only, that is 1 ohm. Now for 4 ohms only. For this apply SL. L is 1, so 1 S. Next here 1 by 4 Henry is there. So apply this formula, we get 1 by 4 S. Now successfully convert time domain into frequency domain. So now completely this is in the frequency domain. Now we are going to apply the loop analysis. It already two loops are there. So apply loop analysis. Now in this step I am going to apply KVL in the first loop. So according to KVL, the source voltage is equal to sum of all the voltage drops. So here this is the source voltage, that is 10 by S. So 10 by S equal to sum of all the voltage drops. So here voltage drops are there. So according to Ohm's law, we know that V equal to IZ. So here we have the impedances 1 ohm and here S by 4 impedance is there. So now we can easily find the voltage drops across resistor. So in this resistor the current was I1 is passing. So according to Ohm's law it becomes I1 to 1 plus, next due to current I1 the voltage drop across S by 4 is, by using Ohm's law, becomes S by 4 into I1 minus of, so from this loop the current I2 is there. It was also entering, creating some voltage drop, means it also taking some participation. So from that I2 into S by 4. Let's consider this is equation 1. Now apply similarly KVL in this loop 2. In this loop there is a current I2 is there. So here voltage drop is 4 into I2 and here 1 into I2, nothing but I2. Next here 1 by 4 S means S by 4 into I2, and here due to I1 also some voltage drop take place at inductor, that will be minus. So minus of 1 by 4 means S by 4 into I1, that's equal to 0. So let's consider this is equation 2. In equation 1, so bring I1 is common here and here I2 is common here. So then we get new equations, that is 10 by S equal to, so from here I1 is common. So here 1 plus S by 4 into I1 minus S by 4 into I2. It becomes third equation. Now similarly rearrange it. So here 4I2 plus I2 but 5I2. So 5I2 S by 4I2 is there. I2 will be common. It becomes 5 plus S by 4 into I2. So by taking common I2 here 4 plus 4 nothing but 5 remains S by 4 into I2. So minus of S by 4 I1. Let consider that's equal to 0. Let consider this is equation 4. Here I1 means I1 of S, I2 means I2 of S. So by solving these two equations we will get I1 of S and I2 of S. How can we solve it? Here I am going to use matrices by using Cramer's method for solving these two equations. At first step, convert these into matrix form. So whenever the equations will be like this, so a1x plus b1y equal to c1, a2x plus b2y is equal to c2. So then we can write these equations as matrix form like this. Means here first equation coefficients, that is a1 b1, and second coefficients, that is a2 b2, x y, x c1 c2. So this is the form of matrix. Like this, convert this into the matrix form. So here I1, I2 are there. So in the place of x, y, I am going to take I1, I2. So remaining blue color data is there. This is A and B. This is A2, B2. This is A1, B1. And here this is C1 and this is C2. Now substitute all the values in the equation. Then we get a matrix form, that is, so here 10 by S is there. This is constant. So here 0 is there, constant. Thus equal to 1 plus S by 4. So in 10 by S equation, I1 coefficient is 1 plus S by 4. Next I2 coefficient is minus S by 4. Next I1 coefficient, that is minus S by 4. Here I2 coefficient, I1 coefficient, I1 coefficient, here I2 coefficient, here also I2 coefficient. I2 is 5 plus S by 4. Into next variables. Here I1, I2. So for this I1 is there, for this I2 variable. So like this only, we are going here I1, I2. Now successfully we write the matrix form. Now first step, here find the determinant for this matrix. So det value equal to, for this matrix as this, it becomes 1 by 4 S square plus 9 by 4 S plus 4. Next we need to find det 1 and det 2. How to find means, so in the place of first column, use constant variables with these values. Replace this column with this column. For that, det will be equal to 40 by S plus 50 by 4. Now similarly, keep this first column as is. In the place of second column, use these values. Means replace minus 4 with 10 by S, replace this value with 0. So for that matrix, we will get det 2. So that is equivalent to 5 by 2. Now we can easily find I1 of S and I2 of S. Here I1 is in terms of S, here I2 also in terms of S. So I1 equal to delta 1 by delta. And I2 equal to delta 2 by delta. So these are det values. Now substitute here, we will get 40 by S plus 50 by 4 upon 1 by 4 S square plus 9 by 4 S plus 4. By simplifying this, we will get 50S plus 160 upon S into S square plus 9S plus 16. Here delta 2 is 5 by 2 upon 1 by 4 S square plus 9 by 4 S plus 4. So by taking LCMs here and by simplifying it, we will get one equation, that is 10 by S square plus 9S plus 16. So this is I1 of S and this is I2 of S. So these are the required equations for the given problem. And this is the process of simplification. Thanks for watching. Please subscribe, like, share. Thanks.